No excuses. I'll do it.
All right, any questions on the homework? Yes, Avery. Let's take a look at number 14, 1, 4, 1, 4, 1, 4. Is that on problems or is that on the normal stuff? The normal stuff, okay. So it says 45 is 5, 6%. Oh, this is the ugly one. 5, 6% of what number? Question mark. Well, clearly I got my is 45. I also got my percent, but the problem is it's a fraction. Turn it to a decimal. What's 5 divided by 6? 5 divided by 6?
0.83.
How much is it?
0.83.
Repeating or not repeating?
No, I don't remember.
I believe it's repeating. So,
I think I rounded, so maybe.
I'm pretty sure it's repeating. It's repeating. Okay. So we get 0, scratch word, 0.83333. Somebody confirm that with me, a calculator. 5 divided by 6.
Yes.
Okay. Avery, we got to change all percents to a decimal. You're like, well, it's already a decimal. It's still a percent. All I did was change 5, 6 to a decimal, but it's still a percent. So how do you change a decimal to a percent? I'm sorry, a percent to a decimal. You move it. See what I mean? You look at this, you're like, well, it must mean 2 to the right. It actually means to the left. This is going to give us a really ugly number, 1 and 2. It's going to give us 0.0083 repeating. And then we have our x. So this is really 45 divided by 0.0083. Calculator, I'm not doing that. Somebody, you're going to need your calculators today too. 45.
5,421,
And the book says the answer is 5,400. So you did a lot of rounding. What did you get, Angie? What was your calculator say? All right. Yeah, the book did a bunch of rounding. Would I put something like that on the test? Heck, no. Yes. Say again? That was 14. Didn't we do that together? Yeah. I know I did this problem with somebody else. Was it Angie? I did it with? I did it with somebody else. All right. Anybody else? Yes.
Number 4 on problems.
4 on problems. It says a town with a population of 27,530 has voted to allot, that means to give, 37.5% of the entire budget to education. If the education budget is 285,000, what's the total budget? So I got a percent, and I have one special word there is, that's your is. So 285,000 is your is. The percent was 37.5, change it to a decimal, so 0.375. Once again, you're solving for that. So whatever that or this divided by that is your answer. By the way, it's a large number. Nobody? All right, on Fridays, I collect homework. I don't, I go, are there any questions? But I just collect the homework. So, Grayson, you know the drill. Everyone else, hey, today is no joke. It is a butt kicker of a day. There's going to be a couple kids out there that are like, I don't know, they're too smart for me. And they're like, I don't know why he's making that. It was easy. Okay, good for you. The rest of us, this is a hard day. How do you get through this day is you got to pay a lot of attention and you got to write down the formula. Hey, there's only 1 through 8. Yeah, they're all butt kickers. Yes, they all require a calculator. No, you won't have a calculator for the test, so therefore I only put 1 of these on a test. If you have good literacy skills, I mean, you can read things and understand them, you will be fine. If you have literacy problems, like, I don't know, I can read 4 sentences and not know a darn thing I just read, this is going to kick your butt. You got to be able to read and understand. 8 problems. For those of you good at it, this is probably 5 minutes worth of work for 8 problems. For those of us, the rest of us that have to read things 40 times to understand them, it's 30 minutes worth of work. The amount of algebra we're about to do is high as well too. Nothing bigger than a 2-step equation, but there's a lot of algebra we're about to do as well. 250, 251, 1 through 8. It's one formula, and it's an easy formula at that. Remember, this chapter is all about every day you get a new formula. New formula today. It's going to look like yesterday's formula. Remember the statement I made a couple days ago? It's like, hey, this whole thing is really just one formula with different words. It's kind of like that today. It's the same basic formula we had yesterday, except we put different words in for is and of. In my adult life, this formula right here for my professional, what I did in the Army, what I did as a teacher, I've used this formula, I can't tell you how many times. Like all the time you try to prove something. Hey, your boss says, what decision should we make, this or that? I use this math right here, easily hundreds of times. Not saying that you might, but many of you will be using this formula. When you ever watch any sports show, this is what they use all the time, this formula right here. All right, here we go. It is entitled percent of increase and decrease, right? Something's either going up or something's going down. If one day I have $5 in my pocket, the next day I have $7 in my pocket, we talk about, yeah, you got $2 more. We also say, hey, something went up by 10%, something went down by 10%. That's this thing called, you hear it all the time, percent of increase, percent of decrease. His passing percentage went down by 4% between the 2 games. You hear this on sports shows all the time. How do they get those numbers? What I'm about to teach you. All right, it is a butt kicker. It's a butt for most students. I should say most students. This is a one that is challenging. All right, here's the idea. Make it stupid simple. I got 4 things. Now I have, this is an increase or a decrease?
Increase.
Okay. The difference is, what's the percentage of increase? That's what we will be calculating. Okay. It's easy to understand we went from 4 to 6, but the question is, what's that percent? Is that 100% increase? 30%. Right. What would be 100% increase from 4?
50%, yeah.
Agreed. So when the numbers are nice and friendly, boy, is it easy, right? Right? What happens if there's 13? Then you grab your calculator, right? All right. What's the opposite of that? I start with this many and I go to that one that is and we need to calculate what's the percent. Hey, did it go down by 50%? Did it go down by 42%? That's what we're about to calculate. So it's not how many are fewer or greater. It's the percent. Okay? Write this down. This is the magic formula. Doesn't it kind of look like the formula from yesterday? Because it is, pun intended. It just doesn't have the word is and of anymore.
Yeah.
It's going to have amount of change.
But there's still one of.
But wasn't the of on this side yesterday? Amount of change is equal to percent times the original amount. Believe it or not, this one is an easier formula to understand than yesterday's, because yesterday you can mix up the is and the of. But this one, hey, original amount, nobody screws that up. Nobody screws up percent. The one you screw up is amount of change. Do you remember the first picture I showed you? What was the amount of change on that first one? 2. You went from 4 dots to 6 dots. That's the amount of change. So how did you calculate that?
I subtracted.
How did you subtract?
You subtract the base and the you subtract the original number to the new number.
But what if it's a decrease? What if it's an increase? Won't that mess things
You
up?
still subtract.
So how are we going to subtract? I'm just going to say the words big minus small. So write that down. The amount of increase or decrease will be the large. You're always going to have a large number and a small number. If it's an increase, right, it's going to be the second number. If it's a decrease, it's going to be the first number. So rather than saying first number minus second or whatever, it's just the big number minus the small number. You're going to have a change. You're always going to have a big number. You're going to have a small number. So it's just large number minus small number. It goes right there for amount of change. You're like, well, it doesn't seem so hard. Yeah, you'll see why it's harder in a second. So you just take the two numbers. Hey, we went from 4 to 6. That's 6 minus 4. That's a 2. Percent of change. What did we do yesterday in the formula? What do we have this as?
A decimal.
It's got to be written as a decimal. So the percent of change will be written as a decimal. And that's it, because I don't need to give you anything for original amount. It's whatever you start with. You start with 6, it's 6. You start with 13, it's 13. Whatever it is, the first number is that you start with. Not the first number in the sentence, but in the scenario, what's the first number you start with? You got to be careful with original amount. You will see when we do some examples, boy, will they try to trick you. I mean, like how they write the problem. On Tuesday, I had 43 items. That was 6 more than how many I had on Monday. Okay, well, did Monday come before Tuesday, or are we talking about the Monday? You'll see what I'm saying when we actually read some of these. Sometimes it's hard to figure out what's the original amount, only because of the way it's written. But it is, in the scenario, what came first? What number came first?
Monday.
You got to be careful with time, because they may say it may go Monday and then 4 days later, right? Or it could be 4 days before. You just got to figure it out. You got to read it carefully. All right, that's the formula. The rest is exactly what you did last night for homework. You're going to plug a number. One of these 3s will be missing. You just do a little bit of algebra. Okay? Doesn't sound that much harder than yesterday. It is. Everybody good?
Yep.
All right, let's see some examples. The book will show 2 methods. I choose to use, it's called method number 1. I'm not giving it a name. I'm going to show you one way of doing it. I think I'm choosing the easier of the 2 methods. Okay. Once again, these will all be word problems. We got to identify 3 things: original number, percent of change, and how much has been changed. The selling price of a baseball glove was $32.50. After sales tax was added, the total cost is now $33.80. What's the percent of the selling? What percent of the selling price was tax? So we're solving for a percent. Which came first? Which came second? We attach tax to it. So this one is as easy as it gets, right? There's going to be no doubt that it's not that the smaller is always the first. It could be the larger, right? When things go on sale, right, then the original price is actually higher than the selling price if something's on sale. Okay. All right, so I got 2 prices right here. We know that this is our original price, $32.50, and then some tax was added. Okay, so this is an increase or a decrease? This is certainly an increase. Okay, so we need to find the amount of change. So given these 2 numbers, how do you find the amount of change? Big minus small. Somebody do it. Big minus small. 1 point. Is he right?
Yeah.
Just because he said so?
No, I mean, I got it.
Okay. So large number minus small number. I got a 33.80, a 32.50. So we do that math and we get 1.3. Okay? Okay? We just solve for amount of change. Percent, that's what they're asking. So I don't know what it is. What was the original amount?
32.50.
And I just see this is pretty easy. That's not that hard.
You just divide those.
Okay, this is the easiest of the easy. So what are we dividing?
32.5. You guys want to attach the tax?
How do you solve for x?
1.3 divided by 32.5.
All right, because we're trying to get x by itself, so get rid of multiplication, we divide. So we're dividing 1.3 both sides by 32.5. Okay, calculator people, you got it. 0.04. What did we do yesterday when we were solving for a percent?
Move twice to the right.
We got to move it twice to the right. Therefore, what's the percent of change?
4.
4%. So actually, that's the tax. Anybody know the tax here in Colorado?
No idea.
I don't know.
I don't have to worry about that yet.
Well, you do, especially if you buy something expensive, right? You buy a PlayStation which costs $500. 4% of $500 isn't like 2 cents. Right? You walk in the store with $500, you're not walking out with a PlayStation. Well, for many reasons.
I mean, if you
One,
want
because
to-
these scammers are buying them all up and selling on eBay for $1,500.
Yeah.
All right.
Oh, you could go and get.
So let's see a much harder one. A share of stock. Stock is for publicly traded companies. They issue pieces of paper called stock. One piece of paper means you'll own a little bit of the company. A share of stock in the Bonanza Gold Mine sold for $15 at the beginning of one day. They have a thing called a stock exchange in New York and Chicago. They have a big room where people scream at each other and say, "I'll buy your shares." "No, I'll sell your shares." "I'll buy your," and they yell at each other. Right? And it's called the stock exchange. And they basically just, that's all they do is sell these little tiny pieces of paper, right? Except they don't physically hand the paper over. It's all done electronically now. A share of stock in the Bonanza Gold Mine is $15 at the beginning of one day. It dropped 32%. What was the price at the end of the day? Oh, this is a hard one. So everybody's really got to pay attention.
That's the starting.
Clearly, this is a decrease because it says it dropped. Of everything up here, what's the easiest number to tease out of the information?
32.
Okay, so that's your percent. You got to raise the decimal to 0.32.
Yeah.
That's easy. How much was the price at the start of the day?
I don't know. Just sold for 15. Oh,
So how much was it at the start of the day?
Yeah.
Well, that's easy. That's your original amount. But the question is, what's the amount of change? I don't know because I don't know the final price. We got to use a variable. So this is where it becomes hard. You got to pay attention now. We're doing a decrease. I'm going to make up some numbers. If I go from 10 to 7, right, that would be a decrease, yes?
Yeah.
Okay. So 10 was the start, and the finish was smaller than the start for decreases, right? We've already said there's a decrease, so this is the scenario. Now let's see if we can plug in numbers. Do we know the start and the finish?
You know,
What's our start?
15.
What's our finish?
Egg.
And what are we supposed to do? Mathematically, what are we supposed to do to find amount of change?
Right. No.
Is that what it says?
No.
Read your paper. You wrote it down in box 1. How do we find original amount?
Percent times original amount.
How do you find amount of change? Sorry. It's subtraction. So this is the amount of change. I don't like that because it's 2 things instead of 1, but that's what it is. So large number minus small number. Where did I get that? I know the original amount is 15. I know it's a decrease, so the second number is smaller. So therefore, the order will matter. I can't just write 15 anywhere I want. It's either the first number or the second number. Since it's a decrease, it's the first number. What if it was an increase? Then that 15 would be the, there you go. Then it would be x minus 15. But this one is 15 minus x. Okay. Questions on where I got that? We said that was going to be 0.32, and we said the original amount was 15. This was ugly. We got a lot of algebra to do here. What's the first thing we should do? Here's our equation.
Solve for egg.
Well, so what's the first thing we should do?
Add 15, subtract 15.
We could subtract 15 from both. We could do that. Is that the easiest thing to do?
No, we do 3.2.
Yeah, how about we do the multiplication first?
Yeah.
So 0.32 times 15. Oh, yeah, this is a calculator. Absolutely.
4.8.
Now what are we going to do?
We're gonna add.
We're trying to get x by itself, right?
We're gonna subtract 15.
So we're going to subtract 15. Can you see it? We're not going to add 15. 15 is positive. So we're going to subtract 15. You got a calculator in your hand. Just hit minus 15.
From 4?
Yeah.
Oh, it'd be like a negative.
Okay, what's the answer?
Negative 10.2.
Do you remember this drill when we had this in algebra? We got a negative on both sides.
Yeah, you have to put the 1 in.
So what do we do? Who is sending me 40 different messages? All right. No, this is a student. All right, what are we gonna do to both sides to get rid of this negative?
Add 10.2.
Add 1.
We could do that. That wasn't the trick I taught you.
Add at 1x.
We could do that. That wasn't the trick I taught you.
Was it
When both sides are negative, what's the easiest thing to do?
drop
the negative.
But mathematically, that's multiplying both sides by -1. So if we multiply both sides by -1, this would become positive, that would become positive. The other trick, and it's not a good trick, is you add x to both sides, you add 10.2 to both sides.
Or could literally figure out.
Or you can literally just erase both negatives, and we get,
Negative 10.
so that's how much the final price was, is $10.20. I told you this was about kicker day. Usually the hardest thing is this right here, is finding out the amount of change. You got to think about it logically, and it does get harder. We okay? We're only going to do a couple of these. We're not doing many of these. All right. Apparently, this is the hardest one. What happens if you don't know the original number? You're going to get 2 x's. Because remember, to find the amount of change, you've got to have the original amount. And on the other side of the equation, you have the original amount. So if you don't know the original amount, you're going to have 2 x's floating around. Just be ready for it. Oh, my word, look at all those words. The number of people who attended the Wildcats basketball game on Friday was 20% fewer than the people who attended Wednesday's game. Okay, now, I don't like this problem. It's in the book. Right? We're assuming that which date comes first, Friday or Wednesday. Okay? That's our assumption. On Friday, 612 people attended the game. How many attended the game on Wednesday? Well, we just go to our formula. This is a decrease. How do I know it's a decrease? It says fewer. Okay. So if it's a decrease, now we got to figure out what came first. What came first, Wednesday or Friday? So I got Wednesday, I got Friday. So that means the original amount is which one, Wednesday or Friday? Do we know how many people came on Wednesday? That's my X. Okay, it's a decrease. Once again, I'm making these numbers up. 10 and a 7. That's a decrease, right? Okay, so if it's a decrease, what happens first? The big number or the small number if it's a decrease? So Wednesday is going to be the big number. So which one gets the X, the Wednesday or the Friday? So this is my X, and Friday is? And what do we do with these two numbers? So there is your original amount, X minus 612. This is all, and now granted, I do this for a living, so I'm probably doing it way too fast. Right? So how did I figure all that out? Well, one, I kind of thought about, well, what does a decrease look like with just strange numbers? Try to wrap my head around what's going on. Two, I wrote down Wednesday, Friday, as they would happen numerically. I don't know. I mean, literally the question says how many came on Wednesday. That's got to be an X. Well, then that would also be the original amount. That's an X. We're given how many people on Friday, 612, but you got to figure out which would come first. If it was an increase, this would be reversed. You know, an increase would be 7 to 10. I'm making those numbers up. So Wednesday would be the 7, Friday would be the 10. So this would be flipped around. So it would be 612 minus X if it was an increase. Once you get a feel for that, then these problems become no big deal. And like I said, there'll be a few of you that like, this is no big deal. But for most of you, you're going to struggle with this. All right. So large number minus small number, we know that, well, the only way a decrease happens is if the first thing is bigger than the second thing. That means Wednesday must be bigger than Friday. We don't know how many people came on Wednesday, so it gets the X. We do know how many people came on Friday at 612. The amount of change is 20, or percent of change is 20%, so that's 0.2. And we don't know the original amount, that's an X. Okay, we got two X's. We got X's on both sides. What do we do? How do we do that?
Oh, a 1 in front of
Do we move the bigger one or the smaller one? So which one's smaller, X or 0.2X? So how do you get rid of 0.2X? Subtract 0.2X from both sides. Jackson said there's a 1 right here. So this is 1 minus 0.2. You can do that in your head.
0.8.
So we get 0.8. We get a 0 there. It's okay. Don't panic. What's the next step?
Get x by itself.
So what's the next step?
You have to
What's the next step?
divide point.
Are you getting rid of the 0.8 or the 612?
612.
We always get rid of addition subtraction next.
If you add,
So add 612 to both sides. You can do that in your head.
so it'd be 0.8x equals 612.
Okay. Last step.
Divide both sides.
All right, calculator people. You can actually do that one pretty easy in your head. Or can you?
I thought 0.001337.
So you can't do this one in your head very easy. I don't think you got the right answer, but what'd you get? You're
Six,
saying
seven.
612 divided by 0.8 is,
675.
675. I was like,
did we get a reasonable answer? I got 765 is what I
yeah,
got.
decrease.
Right, because it's a decrease. We went from 765 to 612. Question.
How did you get
How do we get 0.2? 0.8. Okay. Do you see I got x's on both sides of the equation? When you have x's on both sides, you move the smaller of the two. Which one is smaller, 1 or 0.2? So subtract 0.2 from both sides. What's 1 minus 0.2? There's where the 0.8 came from. Okay. You tell me, yes or no?
No.
Now, typically what happens is I'll have plenty of kids like, okay, yeah, I kind of followed what you did there. And then you get home alone in your room, and you try to do this by yourself, and you start crying. Right. So the only way we get past that is we just do some more. All right. How many more I got left? All right, let's knock out the 2. Ooh, a lot of fewer words. Maybe this one's easier.
Probably not.
Probably not. It says the selling price last year was $220. It was increased by 50%. What's the new price? Okay, so clearly it's an increase. Why?
It says increase.
It says increase. Clearly that's easy. Where does that go?
On the percent place.
So is this original or is this the final price? How do you know that?
Because it says last year.
You kind of see how some of this is not too bad. Okay, so once again, I'm going to make up some numbers. It's an increase. So we're going from 7. I made these numbers up. I have nothing to do with the problem. 7 to 10. Okay, so if you have an increase, this is your first number. This is your last number. What do we know? The first number or the last number?
Last.
So we know the first number or the last. I picked bad words. I saw it. So I'm just saying time-wise, you got something that happens first, you got something that happens last. Is this first or last?
First.
Okay, good. I didn't. Now you're not confused. So my 220 goes right here. We know that if we're doing this, our last number is going, since it's an increase, is going to be larger. So our larger number is going to be last, except we got to do amount of change as big minus small. So we actually need to write it as L minus F, last minus first. Do you know the last number? We don't. It's an X. So since this number will be the larger number, it's going to be X minus 220. Who's lost on where I got that from? Okay, increase. Give me 2 numbers that get bigger. Last week you bought something for, make a number up. What? $10. It's an increase. This week they jacked the price up and now it's $15. Okay? We know our last price. Now I'm put real numbers. Our last price was last year was $220. So last year that would happen first. That would be $220. What I don't know is this one. But we have to do big minus small. Which number is bigger? The first price or the last price if it's an increase? That's why we need to do big. This one will be bigger than this one. That's why it's X minus 220. Okay? All right. We now have enough information to really get it wrong, or I mean to really get it right. This is generally amount of change is the hardest one. That's why if I ask the question, I'll always have people say, I don't get it, right? It's hard to wrap your head around it. So we just do all that process, figured out it's got to be x minus 220. Why? Because if it's an increase, the last number, it's a bad word because it says last year. But timeline as it would happen, the final price, right, would be larger than the original price. There's better words. This is why it's going to be x minus 220, because the final price is bigger than the original price. We said percent was point what? Percent was going to be
15.
and we do know the original amount is 220. All right, this one isn't too bad. What are we doing first?
Add 220.
No.
You have to do the multiplication.
Let's do multiplication first. It's not that you can't add first, and it's just easier to do the multiplication first. Especially if you got a calculator in your hand.
30, 30,
30, 30?
30,
33.
30, 30.
Now what?
Now
Now you have to add
All right, you can do that in your head. So x is?
253.
All right, and that's in dollars, and that's how much the bicycle costs now. So that represents a 15% increase on the original price. It's now 253. I said we have how many left? One more. I'm going to wait 30 seconds, see if you can beat me to the answer. This one is an easy one. If you don't have a calculator in front of you, just set up the problem and then check your work to mine. It says increase, so it's an increase. Amount of change, I always do big number minus small number. Hey, life is good. I got two numbers right here. I don't have to worry, right? Big minus small, that's going to be 288 minus 256. Large number minus small number. I know the original number because it says it increased from 256 to 288. So there's my original number, 256. Now I just need to do the math. Let's see, can I do that in my head? 288 minus 256 would be 2 and a 32, is that right? So 32. 32 equals x times 256. I can't do that division in my head, so I will need some assistance here.
Which one do you put first?
What do you mean, which one do you put first?
Like you put like
Let's solve it algebraically. We're trying to get x by itself, so what are you going to do to both sides? There's your answer right there.
I would thought you would divide by 30.
0.125?
No. Yeah, huh? I got it right here.
0.125, yes, no?
Yes. I got it.
Okay.
I got 8.
Oh, I did it.
Tell me what you did on your calculator.
I did 256.
Look at the problem.
Oh.
I always had big and small.
This is why before your calculator is not your friend, ever. It doesn't care for you. In fact, it probably hates you, right? Your calculator doesn't care whether you touch the number 2 or the number 1. It'll give you an answer. That's called fat fingering your calculator. When you meant to press a 2, but you press a 1 instead. It also is always going to give you an answer. Always, even when you type in something ridiculous, right? Do not trust your calculator. The calculator wants you to fail. So how do you keep yourself from failing? You do the calculation at least twice, and you write the steps down. Okay, so we got 0.125. Is that the answer?
No,
Because
we make a percent.
therefore we need to move the decimal place twice, and therefore the final answer is
12.5%.
12.5%. Okay, this is as easy on this particular one as it gets. When they give you the original number and the final number, this is not that bad. It's harder when they don't give you the original number. That's as hard as it gets. When they don't give you your final number, it's slightly more challenging. Okay? I showed you all 3 flavors as it come from. They don't give you the original number, they don't give you the final number, they don't give you the percent. That's the only way it can be asked. Some of you will struggle mightily with this. I also encourage you to use a calculator on this so you're not worrying about the calculations, you're worrying about the setup. All right. Who wants 5 points of extra credit?
Oh, I do.
I've given it to all my 7th graders and the 10th graders, and no one has gotten it yet. The first person who comes to me and shows me the correct answer gets 5 points of extra credit on whatever you want. There's the problem. The first person who comes to me with the right answer.
Yeah, no, I'm good. I don't need to.
I'm not good.
I can't read it.
A, B, C, D, E times A equals E, 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 E.
I'm gonna take a while.
You need to tell me what A is, what B is, what C is, what D is, and what E is.
Oh,
There is only one right answer.
I don't have that
What are the numbers?
one. I don't know, but 5 points.
The numbers are the numbers in our number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9.
Wait, hold on. 1, 2,
There's not a million.
Wait, no, it's 1, 2, 3, 4, 5.
There's only 6 digits.
just
And then that's
equals
all 5.
No guesses. You got to show me the right answer.
A
Sure.
equals 1.
Yeah, A, B, C, D, E.
No.
1, 2, 3, 4, 5.
Wait, no, but that's it.
It'd be-
Wait, is it just like one? It wouldn't work.
No, yeah, because you have to do
No. Hey, on the bottom here, what does it say the answer is? That means it's either 1, 1, 1, 1, 1, 1, or 2, 2, 2, 2, 2, 2, 2, or 3, 3, 3, 3, 3, so forth and so on. I need to know what each letter stands for.
A equals 1.
Okay, this is gonna take a lot of work.
I solved this in 10 minutes. You can too.
10 minutes?
10 minutes. You can do it in 10 minutes.
0, 1, 2, 3, 4.
So the problem with this is, what's 0 times 4?
0.
0, not 4.
So then you use
All right, we're going to stop right there. E-learners, any questions? There's no e-learners online right now. So we will see you guys on Monday.